Hello all. So this video explains how to do the fifth question of the first classical mechanics homework. So if you look up this problem in Taylor, it gives you a triangle that looks something like this, where you have vertices A, B, and C with corresponding angles, and sides which are denoted by vectors little a, little b, and little c. So part A asks you to prove this equation here, that the area of the triangle can be equated to 1/2 of the magnitude of the cross product of the vectors representing the sides. So this seems a little bit hard to prove, but there's a trick here that's going to make it easier. So we're going to start by orienting this triangle on a coordinate axis. Specifically, what I'm going to do is I'm going to put the origin of my xy plane at point A. So my y-axis is like that, and then my x-axis falls directly on B. So what this means is that I can rewrite vector C to have some component in the x direction and some component in the y direction. And I can rewrite vector B to have some component in the x direction, but nothing in the y direction, since it's entirely on the x-axis. So given that, I'm going to say that B cross C is equal to, using this equation here, bx cy minus by cx. But since I know that by is 0, this term here cancels because it's 0. So I'm only left with bx cy. So what that means is that the cross product of b times c is equal to bx cy. But physically on the triangle, what does that mean? So if we look at the triangle here, bx would be the x component of the vector b, or the base of the triangle here, and cy would be the y component of vector c. So if I go to the end of vector c and I go straight down, that's cy. But on the triangle, what that means is that bx is the base of the triangle, and cy is the height of the triangle. So the magnitude of the cross product of b and c is simply the base times the height. And we know that the area of a triangle is equal to 1/2 base times height, which means that the area of this triangle is equal to 1/2 of the magnitude of the cross product of b and c. So that's how you prove this. I only showed how to do 1/3 of this equation up here, but you can do the other two terms in a similar manner. You'll just change how you define your origin. So for the next term, you would move the origin here, or maybe put C on the x-axis and just go around like that. But for this problem, it's good enough to say that the other two terms can be proved in a similar manner. So that's part A. For part B, we want to prove the law of sines, which for this problem says that C over the sine of gamma equals B over the sine of beta equals A over the sine of alpha. And so note that C, B, and A without the vector sign over them, meaning the magnitude of vectors C, B, and A. And gamma, beta, and alpha are defined on this diagram over here, which is the same as the one in your textbook. So we want to prove this equation starting from that equation in part A, dealing with the cross products. So the area is equal to 1/2 of the magnitude of B cross C, which is 1/2 of the magnitude of A cross B, which is 1/2 the magnitude of C cross A. All right, so I would need to start with this equation and move to the top equation. So first, my current equation does not have any signs in it, but I won't have signs in the equation I'm trying to prove, so I need to somehow introduce a sign. But you know the following relation. The cross product of vectors r and vectors s, their magnitude is simply the magnitude of r times the magnitude of s times the sine of the angle between vectors r and vectors s. So we can introduce signs into our equation using that formula. So we'll have that the area is equal to 1/2 BC times the sine of alpha, which is equal to 1/2 AB times the sine of gamma, which is equal to 1/2 AC sine of beta. And so the angles I pulled from this diagram, so for example, between vectors B and C is the angle alpha, between C and A is the angle beta, and between A and B is the angle gamma. All right, so now I have 1/2 in my equation, but the one I want to prove does not have any 1/2, so I want to get rid of that. So I'm simply going to multiply every term in this equation by 2. So that'll give me 2 times the area is equal to BC sine of alpha, which is equal to AB sine of gamma, which is equal to AC sine of beta. And finally, in the equation I want to prove, the signs are on the denominator of a fraction with no magnitudes next to them, but the magnitudes are on the top. So what I'm going to do is I'm going to take the term ABC and put that in the numerator and do that for each term here. And so when I do that, first I get the signs to be on the bottom of the fraction, and secondly, I'll get all of the magnitudes in the denominators of these fractions to cancel. So what I end up with finally is a term ABC over 2 times the area, which can be ignored, is equal to A over the sine of alpha, which is equal to C over the sine of gamma, which is equal to B over the sine of beta, which is the law of sines, which is what we were trying to prove. So if you don't understand anything that I covered in this tutorial, please let me, Morten, or Jeremy know, and we'll do our best to clear up any misunderstandings you may still have.